All right, so I'm going to go over to this website. And again, if you're on this materials page, all you need to do is click on this hyperlink for code for clean and explore tracks. And you can copy and paste the code from here. One thing I do want to mention as we're starting up here is that I've essentially created different directory structure for organizing these data sets and then the scripts themselves. So you may need to create some folders or modify these file paths. But one thing I highly recommend doing is essentially using what are called R projects. So this is my RStudio window. So my console is the bottom left, my scripts are the top left, my environment's top right, and then my other stuff, so files, plots, everything else is bottom right. And I need to find a way to move this. So if you look at the top here, top right of my screen, I have this kind of tab drop down labeled Behavior and Space Use Workshop. So this is the label for my R project. And this is essentially a consolidated directory that keeps all of my scripts and files and everything else together. So I don't need to worry about like setting my working directory every time. This kind of keeps things contained a bit more. So what I would recommend doing, you don't need to do this, is to essentially, what you won't have this, so you'll just have maybe an empty drop down that says maybe even like untitled. And if you go to this first option, this is new project, and create a new project. This will actually work. And okay, so what you would want to do is create a new directory. A lot of times I'll link these to a GitHub repo, and that way everything, I can kind of sync everything and use version control. So I would use this version control option. But for you, you might want to choose either a new directory to create like a new working directory or folder to do all this workshop information, workshop analyses in. Or if you already created one, you can use an existing directory, but essentially you would just do new project, and then you can browse and look for that location on your computer you want to start this R project. But this will at least keep everything together. So for me, I have this file structure. So I have a folder called process data, where we'll be storing some of our data after we've analyzed it. Another one called raw data, or I'm using underscores here, so I don't have any spaces. That can give, I think, especially Windows, some issues if there are spaces in these file names or folder names. So I have raw data, and that's where I'm going to read my data from. And then I have different folders called R and either behave states or space use. And this is where I'm keeping my R scripts for analyzing these data. So this just keeps everything nice and organized, a little easier to work with. So I'm going to open up this clean and explore tracks script. So again, you can get that from the workshop website, just going to that link for this code. And then hopefully everyone's been able to install the packages I had listed on the website. Okay, so I'm gonna get started here. But if you run into any major issues, just let me know. So I'm first gonna load these packages in. So I'm using the tidyverse for just general data wrangling type of work. Lubridate is being used for date time type of modifications. I'm also loading a package called Plotly, which basically allows you to make these interactive plots that are really useful, especially for like data exploration. I'm loading the package Bayes move, which is a package that I developed related to some of these non-parametric Bayesian models, but also has some resources for data exploration, such as loading your data into a Shiny app and kind of showing maps of where these locations are. I'm also loading in the R Natural Earth package, which is a nice convenient way to load in some essentially like land spatial layers, vector layers for different land boundaries. And then lastly, the SF package for just doing essentially GIS in R. You may have heard of the SP package, which was essentially the predecessor to this, but SP and the raster R package are both getting essentially deprecated soon. So if you are doing GIS-based work in R, I would try to move away from SP or raster towards SF, and then either the Terra package or the STARS package for handling raster data. And there are some packages you might use that are still using SP and raster to do your analyses. And hopefully I would assume that they're going to start moving their code over as well. So I'm going to load all these in just using Command or Control Enter. I'm actually going to close this. Okay. And now I got to charge my laptop. Come on. Okay. All right, so I'm going to load in the data. And like I mentioned just before, for using read CSV, I am including part of the file path in here. So it's referring to my R project as that base directory. So behavior and space use workshop is my base directory for this R project. But then if I go one layer down essentially to raw underscore data, I have that file FDN C- track subset. So that's what I want to load in. And essentially the first thing you want to do after loading in your data, especially if it's a data set you've never looked at before, is you want to get familiar with that data set. So you want to explore it in different ways. So the first line here on line 19 I'm showing is glimpse. And this is essentially the tidyverse version of the str or structure function. So it shows each of these different columns and then some of those initial values from each of the columns and the class of each column. So we have columns labeled PTT, date, longitude, latitude, type, quality, error radius, etc. And this is kind of a cleaned up version of this data set. So if you were to download this directly from like the data provider, it's going to be a bit messier and not exactly like this, but this is, I think, a good way to show this data set. So this PTT column, we see that these are all numbers. So this is labeled an integer, and these are our tag IDs. Whereas date here, we see this set of numbers. So first is year, then month, then day, then hour, minute, seconds. But it's labeling this as a character string, CHR. So eventually we're going to need to change this to a date time format, which is also sometimes labeled a POSIX CT or LT format. Longitude and latitude are both double here, meaning that they're numeric. And then we have things such as type, which is being labeling the type of telemetry. So whether it's FastLock GPS or Argos, and then that location quality. So for FastLock GPS, this value is essentially related to the number of satellites that are present. And if it's anything, it goes from 9 to 4. And then 3210 is related to Argos. And then obviously A, B, and Z. And then here we have things related to our error that was measured by these tags. So in the more recent Argos tags, they'll actually return an error estimate for you, which wasn't the case in earlier versions. So that's using glimpse or structure if you've used that instead. We can also use the summary function on our data sets. And this provides a summarization in a different format. So it shows like the minimum, maximum, and then quartile values, including the mean. So if you have something that's like, in this case, an integer for the ID, or something that's a character, it's not particularly helpful, but it will at least tell you the class here. But it might be more useful for things that are like numeric or integers. So we can see the range of these values. We can see if there's any missing values. So the NA is here. So we see that there's a bunch of missing values for the errors. So this is always good to take a look at, because if there's a bunch of missing values, let's say for the coordinates, longitude, latitude, that could be a problem, and we need to reinvestigate why that was happening. And then I'm using this function n_distinct from the dplyr package in tidyverse to look at the number of unique or distinct individuals. So instead of doing length function wrapped around the unique function, and then this is kind of a quicker abbreviated way to look at that. So this shows that there's 5. So 5 different unique individuals. All right, so we know there's 5 different individuals. We see in our environment, there's roughly 15,000 total observations with 10 different variables. All right, so we'll do a little bit more exploration here on just what this data set looks like. So I'm using the table function, and the table function is essentially just like a counter. It counts up different unique things from your data set. So in this case, I'm going to use it on the PTT column, the type column, and the quality column. And in general, it'll ignore the missing values or NAs by default. But if you use this argument use NA, and there's a few different options here. So I'm using the if any, meaning if there are any NAs to report how many there are. We can count how many unique values there are per ID, how many unique values there are per satellite telemetry type, and then how many per location quality. So for the IDs, we see the ID number at the top row here, and then we see the number of observations per ID just beneath it. So this first individual, 41614, has the fewest observations at 1871. But this next one, 205537, has the most observations at 4,765. But there are 0 missing values, which we would hope, because that would mean that there's a missing ID label. Next, for using table on the type, we see that there are about 9,000 Argos locations and about 5,500 fast-lock GPS. So there's about 12 as many Argos as there are fast-lock GPS locations. And again, no missing values, so that's good. And then lastly, for quality, it's going in this case, numeric order almost, and then showing these letters at the end. So the most numerous appears to be B, the B class, which is often the case. A and B tend to be the most common. And then it decreases in number typically as you go up for Argos up to 3, which is the highest quality. And then everything 4 through 9 is the number of satellites associated with fast-lock GPS. And we see that the greatest number of satellites tend to be in the middle here, the middle quality for fast-lock at 6 and 7 satellites. And that decreases as you get higher or lower from that. We also see that there are 2 locations labeled Z. So these are invalid, and we'll eventually remove these. And there's even 2 observations with no location quality assigned at all, and we'll need to remove these as well. I make a note of that here in this comments in the script. All right, so now we get a general sense of what our data look like and what's there. So now we can start filtering some of these things that we discussed. So some of you may or may not have used pipes before in R, and there's now 2 different pipes. There's like the tidyverse type pipe, and then if you use a more recent version of R, think like 4.1 or later, there's a native version that looks slightly different but does almost the same thing. So here I'm going to be using a pipe operator to basically filter the data by quality. So what I'm going to do is essentially I'm going to push this dat object that has all our data, and using the pipe operator, I want to filter dats based on the column called quality. So For quality, I want it to be not equal. So exclamation, equal sign, not equal to Z. So I want to remove the Z's. And I also want to remove anything that is missing. So is NA. So this is saying I want to keep everything that's not equal to Z and not NA. And I'm going to call this dat2. And we see that we didn't lose many. We only lost 4 observations, and this matches up with the 2 Z or Z locations and the 2 missing values, the 2 NAs. So that's good. And if we run this table function again on quality, just to double check our work, we see that now the Z's or Z's are missing as well as the NAs. So we successfully removed them. But in general, this is good practice if you do any filtering, especially when there's a bunch of observations that you're filtering out, is to make sure that your filter call did what you thought it would do or wanted it to do. So there's plenty of times where I've written code and it actually didn't do exactly what I wanted. And if you continue moving forward with that data set, that's going to be a problem. So just kind of basic data exploration, quality control, just check that it did what it was supposed to do. All right, so we filtered some locations or observations we didn't want to include. Now we need to convert this date column to a date time format, because right now R just sees a character string. It doesn't know it's a date yet. So if we look at the first 10 dates here in this data set, again, we see it's all 4-digit year, then 2-digit month, 2-digit day, and then hours, minutes, seconds. And there's a variety of different ways you can try to read this in as a date time format. I like to use the as date time function from the Lubridate package. So again, I'm using this pipe operator for the dat2 object now. So our filter data sets, and I'm using this mutate function, which basically is from the dplyr package, and it means I want to add a new column or modify an existing column. So in this case, I want to modify the date column that we already have, and I want to make it a date time format. So I'm saying I want the date column here to be date time and assign it back to date. And then a lot of times you'll need to specify what that format is. So if it's already in the format it is now, I wouldn't need to technically do this. But this is kind of providing a template for you if you need to modify this later. So the way that datetime formats are specified are kind of using this syntax where you include in quotes here, either single or double quotes, this type of string where each of these letters are preceded by a percent sign. And each of these have a different meaning. So like %Y is 4-digit year, whereas a lowercase y would mean 2-digit year. And then, however, these are spaced out. So in this case, I'm using dashes. So I include a dash here. If instead I was using like a forward slash, I would include a forward slash in place of these. Percent sign lowercase m means 2-digit month. If I was to use a capital M, that would be what I use here, and that's actually minutes. So again, you need to be careful if you're modifying this string and look at the help documentation to see what each of these would mean. Let's say you have month written out as like a 3-letter abbreviated month. That would be a different abbreviation or indicator here. And then percent sign lowercase d is 2-digit day. Then we have our space, and then we have time here. So capital H is hour, then we have a colon, then capital M is minutes, and then capital S is second. So this should now convert our date column to a date time format. So if we look at those first 10 observations again, we see that now there's a UTC, so like a time zone appended to the end of it. But if I was to do, say, class, and then dat2 date. Okay, so now it's labeling as a POSIX CT or POSIX LT or T format, which is one representation of date time. If I use glimpse again on dat2, this labels it DTTM or date time. So those are essentially meaning the same thing here. So we've successfully converted this to a date time format, meaning now that R can recognize this as a date and time as opposed to just a character, where each one might be considered like a different unique value. So this is kind of boring, but it's really important for analyzing these types of data sets. Okay, so now moving on to some last steps. So to visualize some of these tracks to see if there's any kind of anomalous locations, we're going to do some plotting. But first, I'm going to convert this ID column labeled PTT for Platform Terminal Transmitter to a character. And that's because sometimes when working with numeric like IDs, depending on their value, things can get particularly messed up, especially when using that foie gras package where it'll kind of reorder things depending on that first digit of the number. So you could have 401 be one ID and then like 2000 be another ID. So although 2000 is numerically greater than 400, if they're both initially treated as numbers and then converted to characters, they might be swapped around later because one is smaller than the other ones. The way that they're ordered might go originally from smallest to largest, but then it's converted to a factor where one is, or two comes before four, and then they're reordered a different way. So in general, it's probably safest to convert everything to a character before analyzing your data if they are numbers. So I'm going to convert PTT to a character. And then now I'm going to plot these tracks essentially using ggplot. So if you do all of your GIS in ArcGIS or in QGIS or some other software, this workshop is going to be my plug for trying to use R as GIS. So I'm going to try to blow this up. All right, so here are all of our tracks, our 5 tracks. And we see that there are some large outliers here. So I'm not showing land at the moment, but we see that there's this one path or one segment that's like super long. There's no way that's real. We see some other spikes here jutting out really far away. And it's like impossible that those are real movements. So this is due to some form of location error with the satellite transmissions. So we're going to need to try to find a way to filter these out, ideally ahead of time before analyzing these further. And these are all wildlife computers tags, and those initially originate in Seattle, essentially. So you might see some points, I don't think in this data set, but other tracks you might look at where the initial location is around Seattle, and it's because that's where Wildlife Computers headquarters is, if that's how you're getting your data. All right, so now let's start loading in some land spatial layers. So instead of like loading in a shape file or something, we can directly load in these vector layers in R using this R natural earth package. And there's a few different options, but I'm going to use the any_countries function. So I want to get shape files or spatial vector layers for different countries. And there's 3 different scale options. The finest scale, that's the highest resolution, requires a different package that's causes issues to install. So we're going to use the second best resolution here. And because this is taking, these tracks are next to South America, but then also some of these errors might be closer to North America, I want all the country vector layers for North and South America. So I'm labeling these for continents, which ones I want. And by default, it returns it as an SP object. And I want to do everything with SF. So I want to specify return class as SF here. And I'm calling this object world. So now we see that world is in our directory, or not directory, our environment. And I can print this really quick into the console. And we see inside of it all these different columns. So it says it's a simple feature collection, 51 features, meaning 51 rows and 63 fields or columns. And it's a multi-polygon type, and it's in the XY dimension. It tells us our extent, so our bounding box. In this case, it's has a placeholder for the coordinate reference system. So it's not really defined as of yet. But that's where it would be if you have it defined. And now we're going to add this world vector layers, so these countries, to our plots. And I'm using another function here, chord SF, to define the window's extent. So now we get a sense of where these tracks are in space related to land. So all of this that's shown here is all Brazil, basically. And the location that they're all coming from is the island of Fernando de Noronha off the coast here, where Armando has been doing a lot of work recently to tag these turtles. So thank you to Armando and others who have helped on that project. So we see that there's this one point going like all the way towards land here. And again, yeah, that's impossible. So now we have kind of like a spatial scale to see like how relevant these movements might be. So we see in at least these three turtles, these three individuals, that they've migrated from this island to the mainland. But there's two individuals that don't appear to have left at all, so they're just hanging out at this island. And these are all adult males that were initially tagged during breeding. So these movements towards the mainland are like post-breeding movements to presumably a foraging area. So this is our static plot, and especially it's easy to see these post-breeding movements, these migratory movements. But let's say we wanted to zoom in. Well, that'd be easy to do within the GIS. You just zoom in. But for R, we're just making a static plot, so that's not really possible. But there's this function in the Plotly package called ggplotly. So if we just wrap this code that I just used to make this plot within that ggplotly function, it'll make it an interactive plot that we can zoom in on and pan around on. So now it'll open in your viewer pane in RStudio. And there's these different tools on the top here. So it starts off in zoom. So I can literally zoom in by clicking and dragging a window. And now it'll zoom in on this area. And if you hover over each of these lines, these tracks, it'll, in this case, tell you the longitude, latitude, as well as the ID, because that's how I'm coloring these tracks. So if I really want to zoom in on the islands, now we can see that there's a lot of these kind of spiking movements moving off. A lot of that could be related to location error, but we get a better sense of what's happening. We can use this pan tool and pan around down the length of the track to get a better sense of where this animal, this individual went. And then if we want to zoom in again, we could do that. So that's really nice. If you want to zoom out, there's different options. There's either like a small zoom out where you just click this a couple times. There's also auto scale, which determines like a zoomed out scale. But that would probably reset to the full extent. So we wanted North and South America. And because it's wrapping around from 180 to negative 180 here, or 0 to 360, yeah, negative 180 to positive 180. It has part of Alaska, the Aleutian Islands, wrapped around on this end. If we wanted to reset back to our original plots, we would want to use the reset axes tool, and that zooms back to where we started. There's also options for things such as downloading a plots of whatever you have shown here. So in general, I like using this function a lot when exploring spatial data. So using RS and GIS is made much better by using something such as this function. Okay, so we see a handful of different spiking movements. Another way to kind of explore these data is to use a function from the Bayes Move package called Shiny Tracks, and this opens a Shiny app in R, so an interactive application that allows you to explore these in a slightly different way than Plotly does. So I'm renaming these columns in order to match what is required for this function here, and I need to specify the coordinate reference system. So since it's latitude, longitude, the EPSG code is 4326. So if I run this, as long as you have the Bayes Move package installed, it opens up this Shiny app with just general instructions at the opening page. If I click on the Explore Data tab, It might take a second to load, but now we have a time series plot on the top here. In this case, it starts off with the X column, or in this case, our longitude, but we could choose anything that's in here, and it's only going to plot numeric values. So if you have something that's a character, it won't show up. But let's say we want to plot quality over time. It only shows 0 through 9, so it's not showing A and B because those are characters. But this could be useful for showing changes, like let's say in latitude. We see these different movement patterns that are showing, at least for some of these individuals, that migratory movements. And you can filter by the ID here on the right, dates, any of the columns that's in your data sets, and then it shows a map beneath it. And I could change the base map. And you can zoom in on this. So this provides some nice additional features that's not available by just a simple shiny track, or the plotly function. And then at the bottom, I also have an option for looking at the table of what's here. And if you were to drag over, let's say you only want to look at these individuals that were tagged in 2021, you can click and drag, and it'll only filter and include these individuals. And I'll zoom in on these on this plot. Let's say I want to focus only on, let's say, this movement period for this individual. It'll still show all these time series for these 3 others, but I really am focused on this leg of this individual here, and the other movements that aren't part of that time series are kind of grayed out underneath it. So there's a lot I think you can do in terms of data exploration with this this web application. It's built into this package. And let me open the chat. Okay, so related to Josh and Julia, when did that error pop up for you guys?
It's from running the shiny track.
Okay, that might be related to one of the packages, I would assume. So
it's a data mods package. I think it's a dependency for the phase move package, but for some reason, when you download it, it's not going to the right.
I think at least after we're done running this script, if you were to install that package and then restart R to kind of get it again, so I'm going to try to use that function a little bit later too. That should get it working, I would assume. But let me know if you still have issues with that.
Yep.
All right. So now we want to filter some of these really like large anomalous locations by the study extent, just as a quick, simple way to filter these points out. So based on just this plotly plot, let's say anything in latitude that's less than -3 is something that we want to keep. So we have this one long range movement that's up near 0 degrees, like the equator. And we only want to keep things that's basically that's a real track. So that's one way I'm going to filter out some of these spiked movements. And then same for longitude, anything that's greater than -40, I want to keep. So anything that's east of -40 or west of -40, I want to remove here. So by running that line and then plotting again, it removed a lot of these large spikes. So these are looking much better. There's still this large spike from this one individual and some other movements, but we can deal with that later on in some of these other models. And looking at, again, some time series plots of latitude and longitude. Again, I think this is really important as well, just to get a sense of some anomalous movements that you might not have been able to detect on a map. So I know that's been useful for me when you have some really kind of fine scale movements and it looks like they're all on top of each other, but then you plot something like this, and then you see some patterns stick out that you didn't notice previously. So again, for 205540, we see that spike. Everything else seems to be pretty good. But for these 2 individuals that were residents, we might have some other points filtered out later on. And that's longitude. We can do the same thing for latitude. And these are facet plots that I'm making in ggplot. So I'm able to show these patterns for longitude and latitude for each individual separately. All right, so that's it for the exploratory phase. Now we're going to export this cleaned up data, this initial data we've cleaned up. So that's that DAT3 object we created. I'm just going to use that write.csv function. And the file path I'm assigning here, again, I'm using the different folders. So I have processed underscore data as the folder that I want to save it to. And this requires that you already have a folder called process data. It won't create one for you if you don't have it already. And then I want the file itself to be called cleaned underscore fdnc tracks.csv. And by default, row names is always set to true. So it creates a new column at the beginning, your first column, that just numbers your rows. And that's typically really annoying. And I don't want it. So I'm saying row names to false. So if you run this, you'll end up with a file. And if you're using a folder system like mine, called cleaned fdnc tracks.